up. I sort of wanted to give a little bit of background around how this came to be, because this is really around serendipity in science, if you will. About a year ago, back in June of 2021, out of the blue, I got an email inquiry through Rebecca Beavers, who is the head of the one of the climate adaptation programs for the National Park Service Geologic Resources Division, saying that came through from a gentleman named Sam Witten, who is an engineer for EA Engineers, and said, hey, what do you think about working with this really interesting program called Engineering with Nature that is part of the Army Corps program? And the serendipity part of this is that Jeff, whose credentials you see on the screen, who will be speaking shortly, just happens to be hanging out in Lubec, Maine, of all places. And so just down the road from St. Croix Island, but a colleague of Sam, and then Amy, of course, is also an engineer with EA Engineering. So how this came about is that this is this really amazing program between and you'll hear Jeff speak about what they're doing with this notion around engineering with nature, climate adaptation, that really is incredibly forward thinking and really holistic around how to think about vulnerable coastlines and under climate change. So because Jeff is just down the road from St. Croix Island, and the program is interested in looking at modeling cold climates, this kind of all came together. EA Engineering has been working with the Park Service and continues to on a lot of work around vulnerability in coastal environments, and were brought in thanks to Rebecca's program and a technical assistance to help us with some thinking around not only St. Croix Island, but also Bear Island, so some of our really vulnerable coastal resources. So really amazing string of coincidences that is bringing some of this bringing a lot of capacity to thinking and modeling around St. Croix Island for us. St. Croix Island, as you know, is the monument for St. Croix Island International Historic Site. It's the only historic site in the system. 6.5 acre, tiny little island in the middle of the river that is known as St. Croix today in Passamaquoddy homeland, and has been for some time immemorial, continues to be important to many nations, the United States, Canada, Passamaquoddy, and France, around that recent history since 1604, but as obviously before that has a long history as Passamaquoddy country. So Park Service has been thinking about measuring, monitoring, looking at erosion and impacts on this island for a really long time. And honestly, we struggled with thinking about climate adaptation in the future in a really complex environment. And so this work that Jeff and Amy are going to present to you is going to kind of tee up some new ways of thinking about this. Amy Hunt is an engineer with EA Engineering, and Jeff King, Dr. Jeff King, who's also an engineer, but you can see we'll kick this off. So thank you too.
Yeah. Well, Becky, Abe, thank you so much for the invitation to be with everybody here today. And it's a great pleasure to share information about the Engineering with Nature program, and specifically the St. Croix Island Historic Site that is in our Cold Regions Work Unit. And so, Amy, if you would, maybe we could advance to the next slide. So I thought it would be a good idea to just maybe share a little bit about the Engineering with Nature program before we dive deeper into the St. Croix project. We within the Corps of Engineers have defined Engineering with Nature as this idea of intentionally aligning engineering and natural processes to not only achieve a desired engineering outcome, but do it in a way that we also achieve environmental, social, and economic benefits. And we do all of this through collaboration and partnering. And on the left, you can see the four key elements of what we focus on and prioritize within the Engineering with Nature program. And on the right, you can see many of the different products that we've created over the years. And all of this information and more information about our projects can be found on the Engineering with Nature website. And the Engineering with Nature initiative has been ongoing within the Corps for more than 10 years, but in 2020, Congress appropriated the funds to actually formally establish Engineering with Nature as a program within the Corps of Engineers, and it's been going gangbusters. In terms of the collaboration and partnering, this occurs across all organizational sectors, and it occurs throughout the country in a variety of different ecoregions. We're partnering with academic institutions, we're partnering with the private sector, non-governmental organizations, industry, all to advance this idea of using and leveraging nature-based solutions to achieve many of the desired outcomes for creating resilience and sustainability in these ecoregions. Next slide. For many of you that aren't familiar with our program, our big goal is to revolutionize practice, not only within the Corps, but across all of these different sectors, and really to strive to have nature-based solutions be prioritized as our first approach to creating resilience within communities and for protecting coastlines, and also when working with riverine fluvial systems and in the desert Southwest and beyond. So you can see that we're working in areas like policy to advance practice, the partnering I've already mentioned. You're going to hear more about our research efforts, but certainly research has to be a big part of how you advance this practice. And that includes the science within the U.S. Army's Engineering Research and Development Center, also within laboratories, within academic institutions, as well as constructing projects on the ground and being able to work in core districts, other settings, and also being able to develop these demo projects to demonstrate practice and being able to scale up. And then also, as I mentioned, the strategic communications becomes a big part of our portfolio because we have to be able to message across a very large and diverse set of audiences. So we could be working with practitioners, or we could be working with Congress to be able to help them understand what it means to engineer with nature. And so being able to create these diverse products and have those distributed to decision makers and practitioners is how we're moving the needle to be able to have more engineering with nature projects be developed. Next slide. And this just wanted to quickly offer an example of a project that we would refer to as the gold standard of engineering with nature projects. And this will give you a good example of sort of how this works. So this is a project that the New Orleans district constructed on the Atchafalaya River. And basically, the New Orleans district had run out of capacity for where they were going to place dredge material in the future. And so they began working with us, and we modeled this reach of the Atchafalaya River. And we determined that if we were able to take that dredge sediment and place it in the open water at a particular location, that the river with its natural flow would be able to take that material and deposit it where you sort of see it there on the left, top left, with the island not present, and then over time with that strategic placement of material and it moving downstream and being deposited, an island formed. And this island has grown over time to be about 70 acres in size. And as you can see, it now supports habitat and wildlife, and also has a recreational function with people kayaking and also hunting on the island. But what it did, in fact, was when placing the material there, it actually constricted the width of the river such that it increased the velocity. And now New Orleans district is not having to dredge near as much as they had in the past And they're saving millions of dollars by having this natural feature in the island. And it's also reduced the transit time for the ships and other marine traffic that moves up and down that navigation channel. So this is a classic example of what it is to let nature do the work, to have an island be created, and in the process, enjoy environmental and social benefits. Next slide. And this is just a snapshot of some of the different research projects that are ongoing within the Engineering with Nature portfolio. I've listed 10 here just to give you an example of what's happening within the portfolio. There's over 60 different projects happening right now within this portfolio. And these projects are happening, as I mentioned, all over the country, and really seeing a lot of interesting work and products being generated as a result of these collaborations and publications that are being derived from this work. Next slide. And so finally, wanted to emphasize one of our work units, which is this Cold Regions work unit. And this is a project where the St. Croix Island Historic Site is sort of placed within the portfolio. And this is one that I have been really interested in and fascinated with for quite some time. And we've brought together collaborators, as you can see some of the logos there on the bottom right, that are all very interested in how we can create more resilience in these cold regions for various communities. We're working with a community up in Point Hope, Alaska as well. And the idea here is to leverage all of these organizations and be able to have their expertise, their skill set, to be able to inform how we can create more resilience for these different areas within cold regions. And the idea here is that we can be able to collect this information, to be able to disseminate it broadly for other practitioners interested in working in cold regions, and to be able to identify some demo projects where we can actually move forward in developing some of these features that do create resilience. And so I think that's it for me, and I believe Amy now is going to share more information specifically on the St. Croix Island project. So Amy?
Didn't want to forget to take myself off mute. That was in my head there. Well, thanks, Jeff. We're excited to be working with National Park Service and the Engineering with Nature program and at the St. Croix Island in Maine. And so this is just so what we're calling this project is Preserving History and Engineering with Nature and the National Park Service at St. Croix. So most of you probably know where this is, but I'm not entirely sure where everyone is located, so I figured I'd better play it safe. The island is on the St. Croix River between Calais, Maine and New Brunswick, Canada. It's right here. And a little bit of background, again, most of you probably know this, and Rebecca touched on this at the beginning, but the St. Croix Island was a site of an early attempt at French colonization back in 1604 by the French explorer Pierre Dugas. I was never sure how to pronounce that. But due to the severity of that first winter there, he lost about 35 members of the expedition. And those members' remains were buried on the island, while the remainder of the expedition went on to form France's first permanent settlement in North America, which is at Port Royal. So one can probably imagine they looked at the island and thought, since it was close to the same latitude as France, the climate would most likely be similar, but it would, as we know, it can be pretty harsh there in the winters. So fast forward several hundred years, this island continues to be eroded due to storm surge and rising water levels, and the existing graves on the islands could be impacted. And in fact, based on historic maps of the island, some of these graves most likely have already been lost. And there are some known burials within about 6 feet of the existing bluff. So the objective of this project is to collect information and data and develop conceptual designs that are intended to increase the coastal resiliency while staying in line with the goals of the Engineering with Nature program, as well as creating designs that are permittable and constructible. So EA first became involved with this project through our National Park Service contract, technical contract. So we were providing third-party reviews of technical reports prepared by other engineering firms. And so this was sent to us for our review. And so when we originally reviewed the geotechnical report submitted to National Park Service, we summarized following observations that it's a very steep bluff. It's a 1-to-1 slope and made up primarily of glacial till. The report noted that the erosion was most likely caused by wave action. Surface water runoff could be a contributing factor to the erosion. The tidal range is just under 20 feet out there. And the geotechnical report also recommended protecting the bluff up to the FEMA firm elevation of 21. But we had thought that some consideration should be given to protecting the slope up to the 100-year storm event using the sea level rise scenario, so the existing 100-year storm level is the blue line here, and then incorporating sea level rise for the year 2100, it would be a little higher, so elevation 25. So this photo was taken not quite low tide. This is taken by National Park Service, and you can see where the rack lines are here and where the tide comes up to. But you know, it exposes quite a bit of the island at low tide. And for those of you who have not had the chance to go out to the island, this is just a couple of photos of what the tide range looks like out there. This is also not quite low tide, and this is not quite high tide. So it's a pretty big range out there. So in our summary of the geotechnical report not our summary, but the summary in the report that was written that we reviewed, some of the recommendations were mostly hard armoring for bluff stabilization options. So heavy riprap, steel, precast concrete, really anything with steel and concrete were the recommended alternatives out here. And so we put together a photo rendering of what a steel bin wall with heavy riprap armoring might look like, just the combination of that so that National Park Service could see what something like that might look like. And as you can probably imagine, they were not very excited about seeing something like that out there. So in our summary of the report, we offered to the Park Service that they, you know, perhaps might want to think about more nature-based options as alternative to the hard armoring, like terraces, offshore barriers, nearshore barriers options, like living shorelines. And I guess while nature-based solutions frequently require some more maintenance than hard armor, the dynamic nature of this site and potential impacts from ice mean that this could be an ideal test location to study the resiliency of nature-based options to the types of events that could otherwise cause hard armoring options to fail. And having a system that can self-heal from things like ice impacts is why we were suggesting these types of options and why the research is needed for this location. So after that report was submitted, that's when we started talking with Jeff's group and Rebecca to see if we could maybe take this project a little bit further. So where we are now, for field data collection, our team is out there as we speak, deploying instrumentation to collect high energy storm event data, things like wind, precipitation, wave height, water levels, and velocities in the near vicinity of the island. And the instruments will be out there for about 3 months, and this data will be combined with survey data provided by National Park Service to create a hydrodynamic model of the island. And then that data will be validated against desktop data collected using the closest water level stations and meteorological data stations. And by doing this, we'll be able to calibrate the model to allow for calculations of erosional forces for portions of the year where we're not able to deploy instruments out there. So for the desktop analysis, we looked at geotechnical data from the bluff, as well as collecting samples around the island for sediment transport analysis. And of course, that required coordinating with archaeologists to make sure that what and where we're sampling doesn't cause any issues. We are doing research on ice formation, scour, and ice flows around the island. We're considering extreme tides and where they might come into play as far as scour and erosion. We're also working with ERDIC, Cold Region Research and Engineering Laboratory, collecting historical satellite imagery to perform shoreline and bluff change maps, and working with Park Service to collect topo and some bathymetry. And we're, like I said, deploying the ADCPs and pressure transducers to measure the wave heights, speed, and water levels. We've also got a couple of time-lapse cameras out there and a weather station. And through all this, we've been coordinating with the Passamaquoddy tribes for local ecological knowledge of the island as well. So coordination and planning, as far as coordination, we have a whole lot of project partners here. I'm sure you'll all start seeing more emails, but there's a lot of folks that we're coordinating with on this project. And my first project coordinating with internationally, so that's exciting. The National Park Service has been collecting their own monitoring data, or conducting their own monitoring of the island since 2013. So they've been collecting survey and photogrammetry data to determine changes on the bluff and the shoreline. And additional information is also being collected out there this September, which we'll get also. And this is just another 3D model of the bluff face. This data will be utilized in cooperation with the ERDIC Cold Regions Research and Engineering Laboratory to supplement their research using historic satellite imagery to document the bluff change as well. So these are just a couple of slides to show the windrows we put together to inform when the best window of time would be to deploy the ADCP and pressure transducers out there. So we developed windroses for each month using the last 15 years worth of data from an Eastport NOAA tidal station out there. And the cardinal direction here indicates the direction from where the wind was blowing, and then the length of each one of these spokes indicates how long is a percentage of the month the wind blew from that direction. And then the colors of each spoke indicate the wind speed here. So the blue is more mild conditions, so up to 21 knots, or blue and magenta here. And then the orange and yellow indicate stormier conditions, so a little bit higher knots there, up to 33. So we will remove the instruments in December. So the windrows indicated that the best months to collect data with the stormiest conditions were between mid-August through December. So we'll be removing these instrumentations in December before the ice sets in to avoid any damage. So we have so while we are collecting data, we'll begin the alternatives analysis, and that includes attending a workshop that's right now scheduled for September at the St. Croix Island, or the visitor center there. Actually, I shouldn't say that we don't have a location yet, but we are going on a site visit to the island. And so that will include looking at some of what other folks are doing in these areas and putting together categories of alternatives. Like offshore alternatives, nearshore alternatives, and onshore alternatives. And then after the modeling is completed, and after the workshop, we'll look at what the modeling data is telling us and use that data along with projected sea level rise scenarios to see which of the alternatives could be feasible for the island. And we'll come up with some conceptual designs showing that information, and we'll present that to the Park Service for their consideration. So project timelines, the instrument deployment, like I said, is happening. It was yesterday, today, and tomorrow. And we'll do our alternatives analysis in the fall and winter and prepare a feasibility study in the spring of 2023. And then hopefully be able to release that information the summer of 2023. And potential next steps beyond the current project would be to use the conceptual designs to support grant applications to advance the project to the next steps, and then use the data that we collected to support and encourage other future work in the area for folks working on the same types of projects, taking into consideration climate change risks and vulnerability of coastal areas. I think that's all I have.
Great, thank you guys. Really appreciate that. That was terrific. So we'll open this up for any questions that folks have. And so you can either unmute yourself and go ahead and ask a question, or you can ask a question in the chat. Either one is totally fine. And while everybody,
I have a question.
There we go, Becca, right off the bat.
Sorry, Abe.
No, go for it.
Everyone, in your presentation, you talked about self-healing materials, and I'm not really familiar with that. Do you mind just touching on that a little bit?
Yeah, well, I guess self-healing is basically, anything that is related to, plants and things that are growing in the area, not necessarily, steel and concrete. When it becomes damaged, it's at that point, it's just damaged. So it can't fix itself. But if we're creating something with different types of material, fascines, or anything that's actively growing, that would be considered a self-healing material.
Got it. I'm
overcome being damaged.
Yeah, I thought that you meant there was building material, like man-made building material that can self-heal.
No, that would be great too, but not yet.
Yes. But yes, thank you. I appreciate it.
Other questions?
Amy, this is Jeff. Thank you for offering that presentation and the latest pictures from what was happening yesterday. I was wondering if you, right there. Can you describe what we're seeing right there where you have your cursor?
Sure. Yep. This is a pressure transducer. This is one of 3 that's located on the beach out there. And this is a garden hose that is housing a cable that is connected. It's connected to an atmospheric pressure meter, which, oh no, this one is not. Actually, this cable is connected to a telemetry station. So that telemetry station can't get wet. And so that is transmitting data live. And so we only have one transducer that's transmitting live data. And then the other ones are, we'll have to download that data, but this one tells us what's happening in real time so that we're aware if there's any damage. We also have cameras pointed at these as well, because it's such a remote place, we can't just go out there and check on it. So we have some time-lapse cameras too that we can remote into.
Great.
And that's, I think there were, yeah, so these are the ones I just uploaded today. So this is the weather station going in right here. This is at the top of the bluff. And this is one of the transducers as the tide was coming in. And this is actually the base of the ADCP being unloaded. It was at the gentleman that helped us deploy this equipment. His name is Butch. And this is Butch's house. And this 1,800-pound hunk of concrete showed up in his house. And then they had to transport it to, well, that was the plan, but they were just sort of trying to get the lay of the land and how this is going to work. On Monday afternoon, they all had a powwow there and showed up and tried to figure out what the plan was going to be for Tuesday.
Thank you.
Awesome. Yeah, there's a lot of equipment out there monitoring, collecting a lot of data. Hey.
Yep. Yeah, we're hoping that we have the National Park Service tags on all of our equipment that just, you know, says what project it is and please not to touch it. We're hoping that this area is not an area where there's a lot of, I don't know, nosiness and potential damage, because we didn't really account for that, and just hoping that people just sort of leave it alone.
We usually have pretty good luck with our equipment out in the field. Other questions that folks have?
Not a question, but a comment, which makes me realize that we probably should, would be good to communicate this project in some way to local community. I think this time of year is good because it's less easy for people to get to the island. It starts getting a little more tricky, but you know, we certainly should be sharing how interesting and exciting this work is with everybody in the area. And so maybe we can work on that when we're all together in September too, as well.
That would be
I
fantastic.
have a question. Just, you know, you mentioned that one of your next steps is looking at the alternatives. Do you have a suspicion of what some of the alternatives might, some of the more likely alternatives might be? And might they be creating like barrier islands on that, or other kinds of structures, or anyhow?
We do not. Right now, we're focusing on, we didn't want to get ahead of ourselves. We are focusing on data collection, mostly because in order to move further, we need to determine if the erosional forces are due to heavy storm events. So if it's like high storm events where it's you know, high tide. This is let me see if I can get to a better photo here. You know, high tide storm events where it's hitting the mid bluff, or if they're if it's primarily caused by lower energy storm events where it's primarily just sort of chewing away at the toe, and then you know, the toe is dropping, or if it's based on high velocities out there during different storm events, where it's actually scouring parallel to the shore. So we would need to collect more information to determine what kind of alternative really makes sense out here. But during the workshop, we will present, you know, all kinds of alternatives depending on what the data tells us.
Great. So you're going to be doing a lot of analysis over the next month, right?
Yeah, we won't have a lot of info at that point. We'll be pulling the instruments out in December, but basically during the workshop, we're just going to throw everything out there and say, you know, if this, then we're looking at these types of alternatives, and if this is the cause, then we're looking at these types of alternatives, just to get people to start thinking about it.
And if I could quickly jump in, the idea with the workshop, and we do this for a lot of our more complex projects where we want to assemble a large number of individuals that have knowledge about the history of the area and current circumstances, what have they observed, as well as individuals that have expertise that we can really leverage to better understand what the possibilities are. So for example, we're going to have researchers, engineers, and scientists from ERDIC's Cold Regions Laboratory that will be participating. We've invited researchers from the National Research Council of Canada to participate in this workshop. I believe we'll have individuals from Parks Canada also invited. We'll have engineers from New England District that we expect to also attend. NOAA will be attending. Individuals from the Office for Coastal Management with the information and data that they also have available, as well as the National Center for Coastal Ocean Science out of NOAA will also be in attendance, and academics as well. So we have landscape architects from University of Virginia that will also be there with us to help with integrating some of the ideas of design that are coming out of the different breakout groups. So the idea is if we can assemble this very large group of individuals at an early step in this process and have them iterate and talk collaboratively about what some of these possibilities are, and then us archive that information, we sort of put a marker down as to where we are, what we think are some ideas that we want to have sort of move forward in the process. And then, as Amy mentioned, as the data starts to come back and reveal, what are some of the stressors and some of the energy and risk involved with this particular site, then we integrate that information into the ideas and continue to move this back and forth until ultimately we get some of these ideas that sort of make it to that top tier level of analysis and review.
Yeah, that makes a lot of sense. Sounds like it'll be a fun workshop. Oh, Rebecca, you want to
I wanted to say, I see that Donald is on the call, and Donald, do you have any thoughts from Passamaquoddy?
Yeah, sorry about being late. I had another meeting. I've talked with a lot of local fishermen in the area, and they've noticed that the currents in the water have changed and the direction of wind. I don't know if you're doing any studies on that.
We do have a velocity meter out there, so to measure speeds and direction for the next couple of months.
Yep. Or do you have any past information?
We do. There was a regional model that was put together a couple of years ago, and we are using that data as a benchmark. So we do, but I think I want to say it was 2015, so it's not that old. It's still relatively recent.
And I know a lot of there isn't much talk about the effects of earthquakes. We do have earthquakes in the area, and I wonder, based on the fault line, what changes is that what's taking place?
We have not looked into earthquakes. Actually, that's good information that I will be following up with you with, Donald. Because that hasn't been anything that we've looked into, but we will.
Yeah, we experience about 8 to 10 earthquakes. Some of them go up to I think it's 2.0. The center of the last big earthquake was about a mile south of the island. It'd be interesting to find out if that fault line, what's going on with that, if that could have an effect.
Yep.
Especially since we know this island, it sits on a slippery bedrock and then clay, and then you've got this unconsolidated bluff stuff sitting on top of it. So
Right.
wow. I hadn't even heard of that before either. So that's really good information to think about.
Yeah, any other questions that folks have? Gonna wait out. No other. Oh, Rebecca, you're on mute still. You're on mute, Rebecca.
I was just gonna say, Amy's got a paper on this project that's going to be presented at the National Coastal Wetlands and Resiliency Workshop coming up in New Orleans very soon too. So this is going to be widely disseminated information. So it's all good. Thank you.
Yeah, thank you. If last call for questions, and if not, we'll let everybody go. And it seems like this will be a good one to follow up on a little bit later after you have a chance to have the workshop and then analyze the data in December. So maybe a year from now, we can revisit and find out where things are headed.
Yep.
But thank you guys for taking the time and introducing us to the project. Really look forward to hearing how it goes. It seems like super exciting. I know for the small island out there, it's got a lot of challenges, and it's great that you guys are working on it and looking at a lot of different options. So thank you, really appreciate it. And the recording of this, for those of you who know of folks that couldn't make it today, it'll be posted to the Schoodic Institute YouTube page, hopefully just within the next few days. Thanks a bunch. And Rebecca, did you want to say something?
I was going to
last?
say, Donald, can you hang on for just a minute while we've got Amy and Jeff here? I wanted to check in with you about